All right, so let's move on to Sto Corp and the reason that everyone is here today. First, I want to say thank you to Sto Corp for their support of Passive House Accelerator. Sto Corp is a founding sponsor of our work and helped us get off the ground and provides generous sustaining support. So a big thank you to Sto Corp for that. So Sto Corp is an international technology leader in the design and production of innovative building materials tailored to human needs. Sto is based in Atlanta, Georgia, producing a broad range of advanced cladding, air moisture barrier, and coating systems that deliver energy efficiency and superior aesthetics for building construction, maintenance, and restoration. Sto is committed to developing next generation building solutions, and the company's employees are advocates for technical mastery in pursuit of a sustainable built environment. And we have a couple of those employees with us today. We have Tom Remmele and Zak Veres. Tom is the Vice President of Technical Services and R&D for Sto. He holds several patents related to wall construction and has held technical management positions in the construction industry for more than 35 years. Tom is a past technical committee chair of the EFIS Industry Members Association and holds a degree in architecture from Rensselaer Polytechnic Institute. Zak Veres is the product manager of facade restoration for Sto. For more than 15 years, Zak has held positions in R&D and product management focused on restoration for the construction industry. He holds a degree in international business. So with that, Zak, please take it away, fire up your presentation, and let's get rolling.
Thanks a lot, Zach. I really appreciate that intro. And just to expand a little bit on my role with Sto. So I've been with Sto for just about 3 years now. And almost as soon as I started, was very much, I'm sorry, can you see my screen yet?
Yes, looks great.
Okay, great, thanks. Almost as soon as I started, sort of hit the ground running as far as our restoration efforts are concerned. So within my role, I have a very large focus on deep energy retrofits and passive house. So I'm the guy within Sto sort of that heads up our efforts with Department of Energy grant teams, technical teams, our efforts in NYSERDA and helping NYSERDA reach their New York State efficiency goals and things of that nature. So that's just a little bit more about me. So I'm going to sort of introduce you to Sto, a little bit of who we are, what we do, and why we thought this topic was the right topic to choose. And then I'll introduce Tom, who'll be giving the bulk of the presentation. That he'll be the one that'll get geeky on you. So. So Sto was founded in 1835, actually, in Weissen, Germany, as a cement and lime works plant, and is still our global headquarters today. So that's the mothership, and we operate in 87 countries and employ more than 5,000 people around the globe. So we truly are a global company. And in 1979, we opened the first North American location in Rutland, Vermont, actually. And as we expanded throughout the Americas, our Atlanta facilities became the new and current headquarters for Sto in the Western Hemisphere. So that's sort of our footprint. We have over 250 distribution locations throughout the US and Canada. Manufacturing throughout, and prefabrication manufacturing throughout as well. But really, up at that top right corner, that's really who we are, and that's our culture, and that's why we do what we do with organizations like Passive House Accelerator. So a little bit about what we do. We do facades and we do systems. And whether it's stucco or EIFS or rain screen or prefabricated wall panels and lightweight prefabricated wall panels, what we do in a nutshell is fully tested, engineered building enclosure systems. That's what we are about, completeness, and the entire thing being tested and verified. So we understand that a challenge exists with connectivity out there. Oftentimes on a project, you'll have different products that can lead to different multiple subcontractors, which often leads to a lot of collisions. And on top of that, we're also trying to connect design and construction in an environment of questionable labor and practical experience across different functions. So fully tested engineered building enclosure systems connects products, which can reduce the number of subcontractors, which in turn reduce collisions. And less collisions improves constructability and project delivery. And constructability and project delivery benefits are compounded greatly when you get into prefabrication and actually get that thing off site. So at Sto, we provide these complete systems. We can provide these complete systems with virtually any aesthetic in mind as well, whether it's wood, glass, stone, brick, metal, whatever. We can do it. So in a nutshell, we provide the largest range of aesthetic possibilities on the most complete collection of building enclosure systems in the world. Whether it's new construction, existing, residential, commercial, field built, or prefabricated, that's what we do. So why this topic? We chose this topic because, you know, we could have highlighted a number of different systems or products or projects, but we chose this topic because we believe that educating the audience on this topic provides the best chance for more successful passive house projects to actually happen. It's really that simple, and that's why we're here, and that's what we ultimately want. We want more passive house buildings to exist. That's why we sponsor Passive House Accelerator. We believe that organization and their work provides the best chance for passive house buildings to exist. So that's why we chose this topic. Like I said, it will get geeky. We thought that this was the most important thing for us to present on, for that to happen, and for our first component spotlight with Passive House Accelerator. So without further ado, I'd like to introduce you to Tom Remmele, and he'll go ahead and get us started on the topic. So thank you.
Okay, thanks, Zach and Sydney. Appreciate the opportunity to speak here today, and appreciate the audience's participation and interest in Sto. So I had a couple of objectives concerning air barriers and moisture barriers. If you could post the first one, Zach. When we got into the air barrier business, that was pre-2000, we were obviously a manufacturer, but quickly learned that detailing, continuity, and sequencing were critical for air tightness, and our product in particular was intended to perform not just as an air barrier, but as a waterproofing material. So it had those two functions. And those probably, if you're a finished product manufacturer like we are, often you run into questions or issues of aesthetics. But if you're a total systems manufacturer, as we are, you run into problems or questions about these types of situations, waterproofing and so on. So we've tried to build our products to make them solve complex detailing situations with for the purposes of air tightness, with continuity, sequencing, and simplicity in mind. And so we're going to try to walk through some things that we do and answer any questions that you have along the way. So if you go to the next one. So the photo on the left here depicts a nasty situation in Canada where we've got ice formation, looks like just beneath the parapet. And that situation was actually caused by air leakage. And the detail on the right doesn't necessarily correlate with what's on the left. The left just shows you what can occur if you have a air leakage situation and moist or humid air from the interior in a cold climate escapes into the wall via a crack, a seam, an opening, or a discontinuity in the air barrier. The detail on the right, if you go about halfway down on the call outs, you'll see air and vapor barrier membrane called out. And so that's a line that goes on the sheathing surface. And if you go up further to the parapet situation, you'll find another call out that says lap and seal roof flashing onto air and vapor barrier membrane, adhere with roofing adhesive. And for us, those kinds of things are really, really good because you are able to, in essence, we should be able to draw a continuous line from roof down to wall and maintain that continuity. And so when we draw air barrier details, that's what we try and do, make sure there is a connection between roof membrane, between foundation waterproofing, and the air barrier material that covers the opaque wall. Another thing in here, you can see the double line at the floor or roof situation. That's a deflection situation there, and that calls attention to the fact that there's a special membrane material needed there or treatment needed there to accommodate the movement of that deflection joint. So if you do what's shown on the right and you take all of that into account, then you can have what we believe will be a functional, successful air barrier installation and avoid the kind of situation you see on the left. Now, if you go to the next slide, you'll notice that this is a hot, humid climate we're in. So air leakage issues are not only applicable to cold climates, although initially all of the air barrier standards and interest in codification of air barriers pretty much migrated down from Canada. And as far back as 1980, Canada was concerned about the issue of air leakage through the building envelope, probably because they had those kinds of problems that couldn't be traceable to anything other than air leakage. But again, as we got more heavily involved in the air barrier industry, it became a concern for hot climates as well. In this particular scenario, if you punch the next button, Zach, you can actually have air leakage that goes through a condensate line from the HVAC equipment and moves through openings in the wall, the punch outs and the studs, and is pulled in. That warm, humid air is being pulled in by the fan in the bathroom that's sucking in the moist, humid air from the exterior. It's a conditioned space, so there's the potential for cold spots in the wall, and you can have condensation, mold, and rot occur, as you see on the right-hand picture there. So air leakage is an issue, not only in cold, but really all climates. And so it's become paramount for us in our design, detailing, and assembly of our systems to address that situation as one of our primary areas. The next slide, please. If you look at this detail, and all those blue arrows show air leakage paths and look at the call outs on the left. Or excuse me, let's first look at the roof situation. And if you go to the roof, you see a blue line that is called out as a fully adhered roof membrane. And if you follow that roof membrane at the back side of the parapet up the wall, you'll see that blue line terminates just above the drip edge of the parapet coping. And so you don't have that roof membrane connecting with the air barrier or alleged air barrier that's on the wall. Now, if I go to the wall and I see what's called out as a supposed air barrier, it calls out building paper. And building paper is not an air barrier. It's materially, it doesn't function as an air barrier, and certainly as it's installed with hundreds and hundreds of lap joints that are not taped or sealed in any way, it's never, ever, ever going to perform as an air barrier. So two issues here. We've got no connection of the air barrier, the roof membrane, with the alleged wall air barrier. And second, the wall air barrier is building paper, and it really isn't an air barrier. It's got lap seams that won't enable it to function as an air barrier. Now it is a code prescribed WRB, water resistive barrier, and often the air barrier, and in every case the air barriers that we sell, are performing that dual function, both resisting air leakage to prevent those nasty condensation situations that were depicted in the previous slides, and secondly, performing as a WRB, water resistive barrier, so that in the event water gets through the outer cladding, that's bulk water that gets through, let's say, a cracked mortar joint, you have a secondary plane of protection with that WRB. Another issue here in this detail is the brick tie that you see down on the lower quarter of the drawing at the where the brick tie connects to the studs. And again, it's not sealed in any special way. It's backed with building paper, and we've already seen that building paper is not an air barrier. So that puncture at that location is not necessarily going to be airtight. Another thing that we have here is you have a drop ceiling, and sometimes what will happen is you can have an interior air barrier, meaning the drywall itself that's on the interior gypsum board that's on the interior of the wall can be connected with a drywall ceiling, and that maybe is your air barrier in the envelope. It can, often in residential construction, that's what you'll see, the gypsum board and the gypsum ceiling functioning as an air barrier. But in this case, it couldn't possibly function as an air barrier because it doesn't continue all the way up the stud, nor does it connect with any type of gypsum board beneath the steel joists. So you've got air leakage paths all over the place here. And certainly this is not going to be a airtight building envelope. The other thing, just as a side note, if that's a fire rated wall, you don't have continuity of the gypsum board to give you the fire protection all the way up the wall. And I don't know if it is or isn't in this case, but that's just another reason for continuity of the gypsum board on the interior. Next slide. Yeah, so as we got into the air barrier business, first and foremost, we found we just couldn't make a sheet or a liquid product or something. We had to really, really focus on the joints, seams, gaps, cracks in construction, because those are the vulnerabilities. That's where your air leakage paths are. Those blue arrows, whether it's the joint in the gypsum sheathing on the exterior, or the gap around that pipe penetration, or it's the seam between the steel stud track and the foundation or slab edge, those are all leakage paths. So we have to address those first and foremost. And we do make special materials, one, a flexible membrane called Sto Corp transition membrane for the floor line situation. We make 4 or 5 different joint treatments, depending on who the applicator is. Some can be applied by a trowel trade. Others can be applied by a painter or unskilled laborer. And others can be applied by waterproofers, depending who the contractor is. So we've tailored the products, not just for functionality, but also by trade in some respects. So if I look at this drawing on the left, as far as I'm concerned, you're airtight. You've treated the gaps, cracks, and seams, and but I'm not watertight because I've still got a water-sensitive substrate, meaning the gypsum sheathing, and I've got to protect that in some way. So on top of that assembly, we apply another product called a fluid applied air and moisture barrier. It's applied by paint roller, brush, or spray, and it typically forms the complete air barrier and waterproofing system. And if you'll go to the next slide, you can see here, this is a different product. The green product forms the top coat that goes over the transition materials that go over the parapet. And once again, you see here, we've taken the time to connect the roof membrane with the air barrier and the WRB that's on the substrate. So again, continuity is the key to achieving air tightness. You can go ahead. Now, one of the things about air barriers is it's one thing for an air barrier component like Sto Corp, and Sto Corp is a trade name of ours that we use to represent a family of products that includes really all of the joint treatments and sealants and fluid applied membranes that we have. But each of these materials independently is an air barrier, and that's good, and they meet the standard air barrier requirement for air leakage. There's a standardized ASTM test for that, ASTM E2178. But when you have windows, if you click the next and next, those windows have got to be connected, and typically the seam between the window and the opaque wall is going to be connected in some cases with a urethane spray foam, or in other cases we'll use backer-rotted sealant for that continuity and gap filler. So that again, now we have not just a air barrier material, but we've got an air barrier assembly. The Sto Corp on the opaque wall, the window, which has its own air tightness requirements, and finally the spray foam, which is the bridge between the opaque wall and the code-complying window. And the performance standards for each of those that we have to hit is for an air barrier material, like any one of our joint treatments or the liquid applied product, it's 0.004 CFM per square foot. And for assemblies, as you see here, there's a standard ASTM test, and you have to hit 10 times that. By a factor of 10, you have to reduce the air leakage down to not reduce, I'm sorry, you're allowed a greater air leakage of 0.04 CFM per square foot. So, and for whole buildings, you're allowed 0.4 CFM per square foot. So by a factor of 10, each time you step up from material to assembly to whole building. And that's basically the targets we've got to hit from a performance standpoint for the products and systems. So if you go to the next slide, please. In this particular detail example, if you punch the next button, please. First of all of the basic things we're addressing here with the window, first and foremost, is the rough opening protection. And we have, again, different materials that can do that, trowel applied or roller or spray applied, depending on the trade that's going to install it. And so we first and foremost protect the rough opening. And also down below, you'll see again the brick tie. We have a special gun applied material that's like a sealant applied with a caulking gun. And that brick tie is backed with that backer material to get it airtight after that brick tie is put in, or as that brick tie is put in. If you go to the next button, please. Now you'll see at the head of the window, again, attention to detail. So we need to connect the window frame to the air barrier. So in this particular scenario, we've got an interior air seal that connects from the back side of the window frame to the head of the rough opening. And of course, you have an outer perimeter seal, that's your weather seal, to keep not just air, but also water out. You'll notice at the top, to obtain waterproofing and mainly waterproofing continuity to the exterior, we've used a peel and stick membrane with a termination bar to make that transition over the insulation out onto the back leg of the shelf angle onto a drip edge that ultimately leads any water to the exterior in the event water ever got back into the wall that far. And one last note about the detail, of course, is the use of the insulation that actually brings that shelf angle out further than it would often be. Often that shelf angle is back against the backup structural wall. But again, we do that with the idea of growing concern, certainly in our group here today, about thermal bridging and being able to isolate that shelf angle so that it is not a thermal bridge. Next slide, please. One more situation concerning windows, and we spend a lot of time detailing and testing our product in conjunction with windows, because I call this the no man's land of construction, meaning you've typically got the multiple trades coming into conflict sometimes here, hopefully not conflict, but often it is. I've got the person who puts up the air barrier, I've got the window installer, I've got the sealant installer, so I've got at least 3 trades, and I've got the cladding installer, and they all have their own agendas and instructions for work. And very, very often we find that this no man's land of construction isn't really well thought out and certainly hasn't been tested. You'll find that window manufacturers test the window to meet a certain standard prescribed by code, but often the accessories, the receptors, the sill flashings, and the adjacent components aren't necessarily tested together. So we very, very much encourage, where budget permits it and where the project is large enough, that full assembly be tested for your basic set of air leakage testing, ASTM E283, water penetration testing, ASTM E1105, if it's a field test, E331, if it's a lab test, and finally structural testing, ASTM E330, to verify air tightness, waterproofing integrity, and finally structural integrity of that assembly. Well worth the investment. Those tests can be done probably within the range of $5,000 to $10,000, but for a large enough project, it's well worth the investment. Now, getting back to this detail, we're going to put a flanged window in here, and what you see here is we've actually flashed that flanged window because we've learned over the years that while flanged windows are supposed to leak outbound of the flange, sometimes they leak inbound. And so what we've done is we've put those little round washers or spacers in place. Now if you go to the next slide, and then install the window over that, so I've got a small gap between that lower flange at the sill that, should the window leak inbound to that sill flange, that water can get out. There's about 1/8 of an inch gap there, back out and be flashed out to the exterior. And again, I'm using an interior air seal here of spray foam all the way around the interior perimeter as my air seal that connects to the Sto Guard air and moisture barrier that's on the opaque wall. Now, if I look at the jam condition, those are not furred out, or there's no washers there. So at that jam condition, we're sealing from the flange onto the face of the wall. So all of that's being made watertight. I'm only allowing for water to escape at the sill level. I'm not saying you have to do this. I'm not saying you don't have to do it. It's worth a discussion with the window manufacturer and determining what's the best way to go. Most projects I see, quite frankly, don't do this, but it can be a problem, particularly if you apply the connecting seal that's at the jambs over that sill flange, because then you've really sealed it up to the point where no water is going to be able to escape if it ever got inbound to the nail flange. But if we go to the next slide, please. So at the head, the window is in place, and at the head I've got a counter flash over that sill flange. So next slide, please. We have, again, a very nice way to do this. Again, with fluid applied products, the nice thing about it is I'm not having to cut seams or to lap sheets of material. I can simply trowel or spray or roller apply that material across there, and you can get the correct counter flashing. We always top coat with another layer of the opaque wall material to give us our waterproofing protection, but all of that's seamless. These coatings are, some cases, applied at about 10 mils thick. That's 1/100th of an inch, and they do, even at that thickness, provide air tightness and your waterproofing protection. So, okay, penetrations. In this particular slide, we've got lots of penetrations, round penetrations, and obviously those slits made in the sheet material are going to be difficult to seal with tape and get them truly airtight. Not that it can't be done, but it does require attention, care, and attention to detail in terms of getting it done. And if you go to the next button, please, Zach. And what we've, again, tried to do with the Sto Guard family of products, as you see on the right, that upper photo shows an application of a product called Sto Rapid Guard. It's an interesting product. Chemically, it's an STPE, silyl terminated polyether. And one of the neat things about this product, it was invented by a contractor, really, with the aid of a chemist, to develop a product that would dry in moist, humid, or damp climates like the Northwest or Florida, or really the entire East Coast. You're going to have marine climate, or any coast, you're going to have a marine climate. And the issue was always that, well, some products you apply and, they don't dry fast enough, and rain comes and, then they get washed off the wall. Well, this product actually dries faster with damp conditions or a damp substrate. So it'll dry literally in half an hour under certain conditions, so that seal that's made around that pipe penetration in half an hour's time is airtight and watertight. And you don't have that vulnerability of wet weather adversely affecting the coating. Also, it's applied with a knife, so you can kind of form it around any shape, really, to get a good tight seal, whereas that's rather difficult to achieve with tapes and sheet goods. Not impossible, but not as easy as with this particular product. So if you go to the next slide, please. The drawing on the left depicts, is from an ASTM standard. I don't recall what the standard is, but this is how you are to protect an opening with a self-adhered membrane. And it's 7 steps, but within those 7 steps, there are multiple sub-steps. And if I give this to a contractor and I tell him, here, follow this, and he's got 600 windows to do on a high-rise hotel, it's daunting to get this right. Everything from the little small circular cutouts that you make to, and then subsequently used to seal. If you look at number 5, where the folded up sections are adjoined at the corner with that round cutout, it's tough to do. And so again, to make life easier, we've moved or gone to a fluid applied, so that really, whether I go in, out, up, down, I can move that material. It's a This again is a material that applies with a caulking gun, and it's the same material I talked about before that will dry in damp, humid conditions. And I move it around to conform to the geometry of the opening, and can get, it doesn't have to be pretty, it can be done as long as you get no pinholes or voids, then you'll be airtight and watertight. And I pretty quickly addressed that complex detailing on the left with a fluid applied product on the right. So next slide, please. So next one. If you go to a fluid applied and the Sto Corp line of products in particular, the beauty of it is it's structural. Once you've got it on the concrete or concrete masonry or plywood or gypsum substrate, it's not going to tear or blow off the wall unless the sheathing comes off. And then you've got another problem. That's a structural issue with the attachment of the sheathing. If a repair is needed, if there's mechanical damage at the job site, you can repair that relatively easy with, sometimes if it's gypsum, we use a mesh reinforcement to fix the damaged gypsum, and then overlay that with another application of the coating at the repair area. It's seamless and monolithic. There's no lap seams to worry about, as with tape, and some steps can be done out of sequence. For example, the joint treatment could be done before the liquid applied product is applied or after. And you generally, it's done before, but you could do it after the fact. So you don't have to worry so much about sequence. It's three-dimensional versus two-dimensional, as we showed in some of those prior slides, and can apply easily into opening. There's no origami for the complex geometries that you often see when you've got a lot of ins and outs, returns and recesses. And finally, it helps to obtain continuity of the air barrier on the opaque wall. And last but not least, it reduces risk of failure, which is something none of us want. So if you go to the next slide, getting to Passive House now. This is a project called Concordia Language Villages. The Concordia Language Villages was established in 1961 in Bemidji, Minnesota. And the campus offers language and cultural immersion programs to students from across the United States. So I was asked to facilitate this passive house construction from our parent company in Germany, and who was sponsoring the project. Not our parent company, but the Deutsche Bundesstiftung Umwelt, DBU, was partly funding this project. So we were involved, and was my first involvement with Passive House. And the blue material down at on the bottom floor there is Sto, and the upper floor is our vacuum insulated panels. So this was kind of a collaboration of a lot of different materials, one of which happened to be Sto, the other the VIP panel. And as you'll see, the insulation was a spray foam used between the studs on the interior. So this was the first certified passive house in North America. And as I said, was received a grant from Germany to help fund the construction. So next slide, you can see that the Minnesota code at the time, on the far right there, the bar chart, allowed for almost 100,000 BTUs per square foot per year for your energy consumption, whereas the passive house standard was almost as low as 10,000 BTU per square foot per year. So we were asked to really bring down the energy consumption. And in fact, the end product uses 85% less energy than comparable US buildings. And again, it's not this, with all respect, it's not all Sto, it's a combination of things. And generally in passive house, you're really looking at special windows. We were looking at environmentally responsible building products, materials and chemicals. along with heat recovery, air exchange systems, and as I said, high quality windows and doors. So next slide, please. So there you can see on the right, the joint treatment material that we use. This is a trowel applied material that has a mesh reinforcement, and that's used at the plywood joints as well as the rough opening protection at the opening there. And then on the left-hand side, you've got the overlay of a coating. That's a 10 dry mill coating that's applied over the plywood and over the joint treatments to give you your combination of air barrier and WRB in the final system. The cladding, again, the blue material, is an extra insulation and finish system with 8 inches of expanded polystyrene insulation. And that is glued, so there are no thermal bridges caused by fasteners. That's adhesively attached to the air and moisture barrier. And between it, the 8 inches of expanded polystyrene in the Sto system and the infill of the spray insulation between studs, it was an R70 wall. And as I said, up top, that doesn't have the cladding on it yet. VIP panels were used to clad the top of the building. So the results on the table here, the requirement was annual energy consumption of less than 15 kilowatt hours per square meter, and we ended up at 13.7. For air tightness, there were to be less than 0.6 air changes per hour, and we ended up at 0.18 air changes per hour for a 5,000 square foot building of that was classroom space, studio, dormitory, and common room and staff apartment. So, and since that time, I don't have other examples, but they are on our website. We've become involved in more and more of these passive house projects. And everyone's a little unique in terms of what we're able to do, and then where we've got to maybe use a collaboration of ourselves with another insulating material or other component that's going to get us to the performance we need to be at. So that covers things. I do want to thank everyone for their attention and participation. And there's probably some questions, so I guess we can, if Terry, who's been my cohort on the other side of this, handling the chat box, but if there are any we haven't answered, then we can go through those now, and between Terry and myself and Zach, we should be able to answer them.
Fantastic. Tom, thank you so much. Zach, thank you. Terry, great to be reading your responses in chat. We do have lots of questions, and I would encourage folks to go ahead and ask their question, even if it's been answered in the chat, partly because I think that gives an opportunity to perhaps dive a little bit deeper into the issue, and also so that we can share this with viewers of the recording of this session later. But I'll leave that up to you. And so we're going to start, I should have everyone's name kind of queued up here. We're going to start with Carmel Pratt, and then I have a question from Betsy Agar, who has had to leave, but she asked me to pose her question. And then after that, we'll move to Dr. Jamal Alabid. So Carmel, can we start with you?
Terry actually answered the question. It was not related at all to the products or assembly. It was more general terminology of deflection joints. So thank you.
Okay, sure. Thank you. Thanks for being here. Okay, so Betsy's first question is, that first detail moves the vapor barrier to the cold side. Does that not risk condensation at the wall roof connection? So this is early on in the presentation.
I think that was the first detail.
Yeah.
And that's probably an older detail. Ordinarily, if that, and it's called out as a vapor barrier. And ordinarily in today's world, you'd have continuous insulation over that, where the vapor barrier would be on the warm side of the wall in, say, a cold climate. So again, I pulled that out more to point out the issues of the building paper than the possible issue of I'm sorry, not the building paper. That's the first detail that had the material called out as air and vapor barrier. But yeah, that ordinarily needs to be on the warm side of the wall.
Okay. Okay, cool. Thank you. So then, Dr. Jamal, are you here?
Hello. Yes, I am here. Yeah.
Great. Please, yeah, please.
Yeah.
I think you had a couple of questions, but if you could choose one, and we'll get back to you for the next.
Probably one of the questions that what's concerning me is the fire behavior of the product, and also the moisture level of the protection. So the MU value, that's probably tell us if the product has a risk of the condensation in between the insulation material and the other wall assembly as well. Probably this is one of the questions. Sorry, it's probably 2 or 3 questions in one question.
Yeah. So I think the mu value, we actually don't publish a mu, we publish a perm.
Okay.
Water vapor transmission in perms, and the gold product that I showed there has a water vapor transmission of about 19 perms. So it is a vapor permeable product. We do make a vapor impermeable product that has a perm value of less than 0.1. And so which one is used often just depends on what the construction climate is, or the climate for the project, and what the architect is calling for in terms of water vapor permeability. And as far as, I think the first question you had asked was about the fire, is that?
Yeah,
The fire?
exactly, yeah.
Yeah, so all these products are covered in a ICC evaluation report number 1233 that's on our website. And we test the full assemblies with claddings. And there's an array of claddings that are shown. So you have masonry veneers, you have terracotta, you have Portland cement, stucco, and so on, all of which have been tested or evaluated for use on non-combustible construction with 3 inches of extruded polystyrene per the NFPA 285 test method, as well as NFPA 268 radiant heat ignitability. And then we've done hourly rated walls as well, following ASTME 119. Understanding that the air barrier itself it's a thin film, and it really doesn't contribute much. It's got very, very low flame spread and smoke development values. Nevertheless, back in 2012, there was a code change that said if you have any combustible component in a wall, you have to test that in accordance with NFPA 285. And fortunately, we've done many of these tests with foam plastic insulation because we're in that business of Sto Therm, which is an exterior insulation and finish system. So generally speaking, we've got upwards of 20 or 30 different fire tests to be able to prove performance, either for non-combustible construction or for hourly rated walls. Now, there are some cases where we had a call just yesterday for a metal panel, an MCM panel with our air barrier beneath it. And quite frankly, we raised the red flag there because we don't have metal panels, particularly the metal sandwich panels with foam plastic insulation between them. We don't have that covered in our evaluation report. So for that, we seek outside help with a fire protection engineer to help us assess whether or not that assembly can be used with our air barrier. So we're very, very sensitive to fire because of our history using foam insulation in exterior walls. And I think you had asked if the other one, was there another one here about the spray foam on the interior?
Oh yes, that was, I think, the first question. Yeah.
And Did Terry answer that one, or what was that
Yeah.
question?
I'm not sure if I answered it or not. I thought that the that detail, which was the brick veneer, was really just kind of a setting the stage type of thing, showing a low-tech construction detail and where air leakage could occur. So
Yeah,
Yes.
probably, sorry, that probably not relevant to the to the presentation for today. But can I just add? Sorry, Zach. Can I add just a quick question, please?
Sure.
Regarding the product, yeah, it's just the recommended thickness of the layer that to achieve the probably or meet the passive house requirements for air barrier and moisture barrier as well.
Well, the air barrier that was used on that biohouse project in Bemidji, Minnesota, that's a 10 mil thick product, at least that the part that's going over the plywood. For the joint treatment, that can be about a 1/16 of an inch that goes over the joints, because that's where the most amount of work is needed to resist air leakage, because that's truly an open seam in the construction. The plywood by itself is an air barrier, so we're really only treating the plywood with the coating to get us waterproofing protection.
Thank you so much for answering these questions. Thank you. Thank you.
Thank you. So next up is Trevor Harris. And Trevor, you had a couple questions. I think we should just go through your questions. A couple of them look like they're probably fairly straightforward to answer. And I know they were answered in chat, but it'd be great, I think, for everyone to hear the question and hear the answer.
I'll start with the last one because I've kind of lost the other ones in the chat. So my question was that I was looking at the product brochure for the Sto air seal, and it says that the permeability is greater than 13 perms or 12 perms, sorry.
12 perms, yeah.
Yeah, and so I was wondering is there a maximum point where that maxes out, or is it variable based on temperature or thickness coating, or if I'm thinking about putting an air barrier on the inside like a sheet product and then having the Sto as a WRB, and wanting things to dry to the outside in a cold climate,
Right.
What am I looking at?
So our air barriers are generally going to be in that range of, if they're vapor permeable, somewhere between 10, above 10, and let's say maybe less than 20 perms. And that's about the range we're in. And quite frankly, the reason we published greater than 12 was because it was slightly greater than 12. And when you test these, you won't, there's some variability in testing, so you can be a perm or 2 or 3 or more off sometimes. But generally, the rule, at least in the code, is anything greater than 10 perms is a vapor permeable material. So we feel like we're on safe ground if we're above 10. Now, some folks want it to be higher, like 40 perms or something in the form of our air barriers. We're just not that high. It's very hard to get vapor permeability and at the same time waterproofing. So you're trying to, when we design these products, we're trying to get that sweet spot where we're vapor permeable. So we have that covered, but we're also watertight. Now, on the other end of the spectrum, we do have a product that is less than 0.1 perm, vapor impermeable. So that question that was asked before, you could have your insulation on the outside and the interior vapor barrier on the sheathing as your vapor barrier, and not have a dew point in the construction.
And then in terms of, you're building a passive house for 100 years. What do you expect the lifetime is for the liquid applied membranes in terms, before they get brittle, before they kind of wear out on the interior of your?
Probably the most vulnerable part is going to be a moving joint. And we go through aging tests that are required not just by the US, but by Canada, heat aging and cyclical movement. So we basically run it up to the standard that we're required to meet. I believe the product will last the life of the structure unless there's some kind of mechanical damage that occurs through whatever, through a renovation or something else. Once they're protected with the cladding, they're really, the only thing they're exposed to is really the movement of the structure. And we do have our products, the one product that we make for dynamic condition is a product that's looped into the expansion joint, let's say, so that it's never under stress, because it can expand and contract without being in tension when the joint opens up. And we purposefully did it that way so it wouldn't be under stress.
Thank you.
Fantastic, Trevor. Yeah, good, great questions. All right, so next up is Jane Sanders. Jane, it's great to have you here after last night's fantastic presentation at the happy hour. Please fire away here.
Yeah, I was just asking about what the differences are between the gold coat, emerald coat, air seal, and vapor seal, and he answered that in the chat. Basically, the emerald coat, it says, is for cladding other than EIFS. Air seal is for, or no, gold coat is for EIFS.
Yeah.
And then the air seal is a high build, and the vapor seal is vapor impermeable. So I'm mainly interested in the difference between the gold and the emerald, because in the past, when I checked it, the emerald was more permeable than the gold. And recently I looked at your specs and it's reversed.
Yes. What we did is in the early development, these products, two products were developed, the gold one in 2000 and the emerald one in 2006, I believe it was. And the original gold coat had a low perm value, less than 10 perms. I think it was right at about five perms. As time wore on, there seemed to be more and more demand for the vapor permeable. So we made a shift back sometime after 2010 to a vapor permeable gold coat. And quite frankly, the only difference, I'd say, there is a chemistry difference where one is a acrylic product, the gold coat, and it has a better UV resistance, so it can withstand exposure for a longer period of time, let's say 6 months, even to a year, whereas the emerald coat product is a styrene butadiene rubber chemistry, and those by nature are less UV durable, and so for that we'll have a lower limit in terms of UV exposure. And that becomes important if you have a job that's going to, be dormant for 6 months or something because of weather, and then you definitely want the product with the higher UV exposure. So that's one difference between them. And the other is that we really designated the gold one for EIFS, Sto Therm, and the green one in the past has been designated for stucco because we kind of sell to two different contracting trades and we wanted to be able to differentiate them. But in terms of standards compliance, they all meet the same standards, whether it's the standards for air leakage or the standards for waterproofing.
Okay, so if you use the gold, if we prefer the gold because it's slightly more permeable, is there any reason not to use that for stucco?
No. In fact, we're probably on the verge of doing that.
Right. Okay.
Because it avoids just the kinds of confusion and questions. We're better off just to have the one vapor permeable product and use it beneath EIFS and stucco. And that's so we basically don't have any constraint there or recommendation not to do it. It can be used equally between both or underneath both claddings.
Okay, great. And then I had another question, which is more of just a product request. I was noticing in the window details, where you show the wood bucks And there's always an issue of when your window is not in line with the insulation layer, how
Yes.
to best make the transition. And this is a huge thing in retrofits.
Yes, yes,
It would be great to have something to use instead of the wood blocking that was an insulating material that's waterproof, but that you can use as bogging and screw into. And, you know, I've used products like compact foam, and there's a product by Partel called Almavert, but, you know, they're still pretty expensive and only available in sheets. So something that was available in a blocking form that was waterproof, that could be part of a whole system,
right.
would be just.
So you're looking for a thermal product that you can anchor the window into that's not the wood buck.
Right. And I know there's a company making it for something for residential construction, but that's mainly for flange mounted windows. I forget the name.
Right.
And that one you can't actually screw into it. You have to screw through it into the structure behind it. So
Right, right.
yeah, something to
Well,
keep for future products.
we'll look out for that, because I honestly don't know today what else is out there. But it's a good point and something we need to look into.
Oh, I'm taking notes, Tom.
Okay.
Great. Jane, are you good?
I'm good, thank you.
All right, thanks. So we had another question from Betsy Agar. So she says, I'm hoping you'll discuss air barrier solutions for floors over unconditioned spaces in prefabricated panel construction. Where should the air barrier go?
For the floor?
Yeah.
Oh,
Floors over unconditioned spaces, yeah.
okay. Honestly, we're not in that business, so I don't want to venture a guess here. And I really want to look at that a little more carefully before.
Okay.
I don't want to give you wrong information. That one is just not in our wheelhouse.
Yeah, got it.
That is.
So while I'm on Betsy's questions, here's one more. How do you detail the corners of the WRB at the corners? Metal end dams are not enough protection, but where 3 different planes converge at corners, they're difficult to detail with membrane.
Yeah, and what we do is, if again, I go back to that product called Rapid Guard, where you have 2 budding planes, we take that Rapid Guard and apply it as a cant bead all along the seam where, say, a budding sheathing might have joined. So we'll apply it as a cant bead. Then as it takes up, we'll come back again and go over it again with applying the material to the rest of the flat areas of the wall or sill construction. So that's how we would do that. I don't know if that got to your question or not.
Well, Betsy's not here, so we don't know for sure, but that sounded like a really good answer to me. Thanks. Okay, so next up is Maureen Shea. You had a question about the metal flashing and thermal bridging.
Oh, okay, sorry. So yeah, I guess I saw that you had the flashing going back to the substrate, so it wouldn't be, there would be no thermal break there. And
Yeah.
I guess that I had the other question as well about just generally the systems, because we've been trying to use the Sto mineral therm system, but I don't think the details that are used for the US product are the same as the passive house details in Germany.
Right. So to answer your question, so there are alternate materials that we can use for flashing. Sometimes PVC has been used as a flashing material, so you don't have that thermal bridge. For the Sto Therm mineral system, no, we don't have that configured in a passive house type situation. But theoretically, you could do it. What I think one of the difficulties with that assembly is you do have mechanical fasteners for that system, because the mineral wool by nature is even though it's a high density mineral wool, it's relatively weak. because of the fibrous nature of the material. So you have to use a long pin. So if you were going to go with 6 or 8 inches or 10 inches of mineral wool, your pin now has to be quite long, and it becomes quite expensive, but not undoable. And so I think there's a way we could get to passive house depending on what thickness you're looking for or will need in the exterior insulation.
Yeah, and also I did speak about getting some of these PH starter pieces. They have these 2 pieces that they use in the German details, so that they're actually designed to hold the stucco system. Do you know the pieces I'm talking about?
Yeah, I think the PH starter tracks, is that?
Yes, that's exactly it. So I guess, I've been in conversation with some people about using them, and I guess potentially they could be used at the window heads as well. Is that correct?
Yes. Yes. Yeah. Yes, I think that could be done. And there are some, depending on the detail, there are some ways there are parts available domestically here in the U.S., not from Sto Corp, but from other vendors we work with that are PVC that could be utilized potentially for the same purposes. But again, you're interested in that termination at grade and also the possibility of using it at the window head.
Yes, yeah. Well, just anywhere where you would probably be showing, thermal bridging that's just caused by, in the general sense, just the system at the system level.
Right.
So I guess I just wanted, maybe I can follow up with someone to get other recommendations. I hope we'll be able to get the passive house pieces. I guess it's just a little coordination with how we order them or whatever.
Yeah, it's possible. It does involve some coordination, as you say, with our German colleagues.
And also just, I guess, if, I know that they had, for some reason, it doesn't seem to be on the German website anymore, the full, or at least I couldn't find it, the full set of passive house details for the mineral therm. They seem to have gone over to the what is it called, the wood insulation product for that. But I would definitely like to just have a set of their details, even if it's in German, just to have it on hand.
Okay, let us look into that for you.
And also, they don't typically show the window head details in any of the German details. Do you know why that is?
No, I don't. I'll have to ask them that. So that's a good question.
Okay, well, thank you. We want to be able to not use plastic foam insulation, and so that we're really interested in this idea of using the mineral therm.
Right.
Because it has, it's just a simpler, hopefully it's a simpler assembly process than using a wall, what do you call it? The wall system where you have the gap, the rain screen system.
Oh, the ventilated rain screen, yeah.
Yeah, so this would be potentially, something that would be labor saving, and we could still, we could have these walls.
Do you know offhand what thickness of insulation is involved?
I think we're actually only probably going to use 4 for most of them.
What, 4?
4, maybe at the outside 5 inches. And one of them is only 2 inches, but it's not a passive house. Or maybe it was 3. Sorry, 3. My mistake.
Okay. Well, that's that insulation is. We work with Owens Corning, who makes the Stotherm board and insulation board for the mineral wool system, and that's available here in the U.S., so that's not a problem. The accessories are the ones that we'd have to bring those over.
Right. Yeah. I mean, it looks like, it's partially considered. I guess it would be good to just have someone say, wow, we know people want to use this because they don't want to use foam insulation.
Mm-hmm. Yeah.
For the passive house. And, so there's some sort of literature to support that use. That would be great.
Right. Okay.
Great, Maureen, thank you.
You're welcome.
All right, so next up is Ken Kloss. I see Ken here. Ken, can you unmute yourself? Both you
There
and
you go.
Okay, great.
Am I on? Okay.
Yep.
Okay, my question has to do with a real simple thing. Sometimes construction stalls midway, finances or whatever. I'm wondering how Stogard lasts as far as ultraviolet degradation.
Yeah, so as that came up a little bit before, but the gold product, Sto Gold Coat, will last 6 months to a year. Not that it will last. I mean, it will last a lot longer than that. But as a guideline, the longer it's out there, you know, it's not a permanent, intended for permanent exposure. Likewise, the air seal product is a good year. So if you have those stalls, as you say, those would be the two products that have the added UV resistant Sto Gold Coat, which is your vapor permeable thin film product, and Sto Air Seal, which is your vapor permeable thicker film product.
Thank you.
Great, thanks, Ken. And Enrique, you had a very similar question. Did it get answered for you, or do you have more that you'd like to dive into?
Partially, but in the bio house, you seem to have that Stogard as a exterior coating. Is that the way it was used, or why is it different color than the one that you have on the 7-story building there?
So they are the same product, Sto Gold Coat on the 7-story building that had the penetrations and so on. And then the product that was used on the Biohouse project. I think the reason the color looks different is as we got into this business, some people complained that the product was too translucent, so you could see.
No, but I'm referring to the foundation, the blue one, the Biohouse. Wasn't that the same Stogard?
Well, that blue material is actually a finish. That's a textured finish that was applied as the finish coat for the extra insulation and finish system. So the finish was blue, and that's not the air barrier. That's just the color that they chose for that level of the building.
Okay, so it cannot be used as exterior finish then?
The air barrier? No.
The fluid Stogard.
No, you have to use it as an air barrier. It's not intended as a finished product.
Okay, thanks.
Awesome, thanks, Enrique. So next up was Sean Borman, but it looks like Sean has left the meeting. So we have Helena Garrick, if I pronounced that correctly. And both of your questions were addressing concerns
very
about
similar.
off-gassing. Yeah.
Yeah, exactly. So just off-gassing or VOCs, any information when it comes to that, or the fluid applied materials.
Yeah, we build all these products to comply with the strictest air quality standard in the U.S. That's the South Coast Air Quality Management District in Southern California. So they all are VOC less than 50 grams per liter. That's a standard requirement we have, and they're all water-based, so very user-friendly. They are going to have a slight odor, not significant, but a slight odor when you open a pail of the material. But as far as off-gassing, there isn't enough volatiles there to, particularly if it's outside, which most of the time it is, that would be of any concern.
Okay, sounds good. Thank you.
Great question. Thank you. All right, so next up is Danny Liu. Danny, I think you need to unmute yourself there. I do see you there. And I'll wait a moment and maybe just ask the question for you. Okay, I will ask the question for you. So the question is there any compatibility issue with applying the fluid applied on roof torch-ons or granulated surfaces?
Yeah, I don't think you can take the fluid applied and bring it over a torch roof granulated membrane surface. At least I don't have anything that supports that form of testing and so on. And that's why typically we show, or we try to depict the membrane coming back over onto us or onto the Sto guard with a lap seam and chemically adhered as opposed to torch applied.
Great, thank you. So Alan Lehman looks like is not on the call, so I'm going to skip over to Daniel. Half of you had a question about other installations that are not combustible, like mineral wool. Daniel, you need to unmute yourself.
Am I auto unmute? Good.
Okay, great. Hey, Daniel.
Okay. Yes. Yes. Thank you very much. The answers to the previous questions answered my question. The Sto Therm CI looks great, and I'm on the computer right now looking it up, and it looks great. I thank you very much.
Fantastic. Thanks, Daniel. And last but not least, in terms of questions, we have Hans Eich. Hans, you had a couple questions, I think.
Yeah, just one really relating to stucco on top of the systems. I know that here in Ontario, we've had issues where stucco got wet due to condensation behind it. And so I think the OAA then completely forbid the use of that. But from my understanding, it's just the perm rating. Do you have vapor permeable stuccos that go with these systems, or?
Well, the stucco is vapor permeable, and then the finish on top of the stucco is also vapor permeable. But as a composite, what happens with stucco, and I've found this more in moist, humid climates, is that if you have any kind of bulk water intrusion, say from a leak at a window or some other area of the construction, the water has a tough time drying by diffusion. So our recommendation is always to use what we call a drain screen, which is a tangled filament product that goes behind the stucco and creates about a 10 millimeter gap like you have out in Vancouver. So we think that's a good solution. And I don't think I've rarely seen problems that are solely caused by water vapor diffusion, where the amount of water in the wall is so much that, you know, it's causing a substantial problem. Most of the problems I've seen with stucco are bulk water infiltration, and once it gets in, it has limited ability to dry. And as I said, for that reason, we prescribe a drainage mat, 10 millimeter mat, beneath the stucco, particularly for wet climate zones.
Okay. Well, thanks.
Thank you.
Fantastic. Thanks, Hans. So we do actually have a couple more questions. We're not ready to let you go yet, if that's all right, Tom and Zach and Terry. Okay, so Jane, you had another question.
Oh yeah, this was just another product interest, and something that supposedly is available in Europe by Sto is a board for interior insulation. That's a combination insulation and finish that could be applied over an existing wall finish, and it contains aerogel.
Yes.
I don't know if you've heard of it.
Yeah, that's a system called Sto Thermin, and they have a board over there, an aerogel board that can be used for interior retrofits that combines with some gasketed tapes and so on to make an airtight envelope on the interior, at the same time gaining the insulating value. The reality is that for us, we've looked at that system, and you know, we always have to look at it if you're a manufacturer from the business side, and we can't seem to justify, you know, the value in developing it, at least not at this point in time. But there is such a system in Germany, and it's just as you said, for interior retrofit.
Excellent. Thanks, Jane. And we have a question from Dr. Jamal.
Hello, just inquiring about the project, the Sto projects are available in the UK or On the cost, please, as well. Please.
In the UK, yes, they're available in the UK. And where else did you say?
No, it's in Scotland, so our project
Yeah,
is mostly in Scotland.
it will be available through our affiliate or our subsidiary.
Yes, and the cost compared to the conventional one that we use here, like Pro, Climber, or the usually use if in the Typhic guard sheets, not really.
Cost of Sto Guard is going to be comparable as long as you compare apples to apples. By that I mean using the sheet tapes, the special fasteners, and the flashing membranes and so on for rough openings. There's a more or less equal cost comparison. But I qualify that with the fact that, you know, we have a lot of special detailing components, and the sheet manufacturers also now have special detailing components. So you've got to make sure that it's not just staples that are putting up the sheet, but the actual fasteners that the manufacturer prescribes.
Okay, thank you. Thank you so much for that.
All right, thank you. So that brings us to the conclusion of the questions and answers here. Tom and Zach and Terry, thank you so much. I don't know if there's anything else you want to add. This has been really informative, and wow, we're like 90 minutes into this here with great information. So I guess I'll pause and see if you have anything else to add, and if not, I'll make some thank yous and we can close up.
Well,
I just personally wanted to thank everyone for their interest in participation, and it's nice to see this kind of involvement and interest in Passive House, and obviously the questions about Sto we love to hear. And you know, you gave us a couple of things to track down, which I'm gonna say Zach will do that. So I'm gonna hand it over to Zach.
Yeah, I'll make it real quick since we're 90 minutes in, but of course we appreciate you guys' time. Especially Jane, thank you. We especially appreciate the product requests and knowing about your pains and where we can help. And I would just say in closing, just you know, if you're working on projects whether it's in collaboration with the DOE grant team or you're doing it on your own or with NYSERDA, please feel free to reach out to me directly. I would be your primary Sto contact for something like that, and we're always looking for things like that. We're working on some really cool stuff that I can't talk about right now, unfortunately. Sorry. Hate to tease you like that, but we're working on some pretty cool stuff, and we're always looking at the next best thing and the next cool thing too. So feel free to reach out to me directly with your projects. Thanks.
Fantastic. So, you know, the transition to high performance building and Passive House depends on innovations by builders and tradespeople and designers and architects, and absolutely on manufacturers. So I'm just really happy to see the leadership that Sto is taking and to learn more about your products here, and to have the chance to engage with you on this. Thank you everyone for attending today's presentation, and we really appreciate you being here. And this will be available on video soon. So if you want to review what you learned today, or if you want to share this with colleagues, we'll have it published by next week. So with that, on behalf of Passive House Accelerator, thank you very much and have a great day. We'll see you later.
Thank you, Zach.
All right, take care.